Hi Trig students, this is Megan, and in this video I'm going to be talking about section 9.2, which is over the law of sines, in order to make up for the class that had to be canceled on Monday, October 27th. So hopefully you've heard of the law of sines before. It is in most high school curriculums. The formula for the law of sines goes like this. It's basically just a proportion, which is two ratios. So the law of sines says that the sine of A divided by A, notice the difference in capitalization versus lowercase, is always equal to the sine of B over B, and we could make a third ratio equaling it to the sine of C over C. And each time you're going to choose two ratios. So depending on whether you're working with angle A, angle B, or angle C, you'll choose two each time. Alright, so it's important to remember that the capital letters A, B, and C are all angles, while the lowercase letters A, B, and C are all sides that are opposite the corresponding letter angle. Because what's going to be given to you in a problem are just values, and you're going to need to draw your own diagram matching the appropriate capital letter and lowercase letter labels. So this formula is best used for non-right triangles. So in section 9.1, we used sine, cosine, and tangent equations, basically SOHCAHTOA with your opposite and your adjacent and your hypotenuse. We used those equations in order to solve right triangles. So now we're going to move on to non-right triangles, and the law of sines is going to be your best option. Now, the law of sines does also work for right triangles, so it can be used in a lot of different ways, but most of the time it's a harder process than just using regular sine, cosine, tangent equations. Alright, so we've got some different types of triangles based on what's given. We have triangles that are called SAA, triangles that are called ASA, and triangles that are called ASS. So these three types of triangles are useful in the law of sines, or the law of sines can be applied to these three types of triangles. So basically what you have here with SSA is you have one side and two angles given. One side and two angles given. In the second case, the ASA, you also have one side and two angles, but here what happens is that the side occurs in between the two angles. And I'll show you a diagram of that in just a second. The ASS case obviously spells a particular word, and this is what's called the ambiguous case, if you're familiar with that. If not, we'll go over what that means. But in the ambiguous case, we're given one angle and two sides. Alright, so these first two, where you have one side and two angles, are fairly straightforward. And then the ambiguous case has a couple of different scenarios that we need to review. So let's start off with an SAA triangle example. Okay. So in this example, we're going to be given one side and then two angles. So we're given capital letter A equals 35 degrees, capital letter C equals 15 degrees, and lowercase b equals 5. So the first thing that we want to do is draw the diagram, or draw and label the triangle. So again, we don't know really what kind of triangle is, whether it's obtuse or acute. We could figure it out fairly easily, but it doesn't really matter. We just need a triangle. And again, a triangle has 3 angles labeled with capital letters and 3 sides labeled with lowercase letters that are opposite the corresponding letter angle. So let's fill in what we're given. So we know that angle A is 35 degrees, and we know that angle C is 15 degrees, and we also have that side B is 5. And I had my labels mixed up, so I want you guys to go back and change this. This is not an SAA example, it's actually an ASA example. And let me explain why. So here we've got 2 angles given and a side. But what's important to note is that this side is occurring right in between the 2 angles. Okay, so the side that is known is the side that's adjacent to the 2 angles that are given. So ultimately it really doesn't matter if you're able to identify the difference between SAA and ASA. You solve the problems the exact same way, but I had mislabeled my example there, ASA. Alright, so in order to solve, let's figure out what it is we need to find in order to complete this triangle. So we know angle A and we know angle C, but we don't know angle B. And everything is in degrees here. We're not working with any radians at all. We know side B, but we don't know side A or side C. So these are the things that we're trying to find in order to solve this triangle. Let's start with angle B. So angle B is something that we can find without using the law of sines. And for angle B, we can just use the angle sum theorem, which tells us that a triangle's angles should add up to 180 degrees. So if we do 180 minus the 2 angles that we know, 180 minus 35 minus 15, we should get 130 degrees. Okay. So we've got an angle and we didn't have to use the law of sines yet, so we know we're going to have to use it soon. Let's try solving for side A. Okay, now with side A, we're looking to figure out the length of this side right here. We know the angle that's opposite that side is 35 degrees. So we can write a ratio, the sine of 35 degrees over A. The law of sines says that we need to set that equal to another ratio of the sine of an angle over its opposite side. But in this case, we wouldn't want to use C. We wouldn't want to use angle C and side C because we'd get another variable, which isn't helpful. So instead, we would want to use the 130 degrees that we found for angle B and its opposite side 5, because that way our equation will only have one variable in it. Alright, so hopefully you remember how to solve proportions. We cross multiply in order to do that. So I'm going to multiply A times the sine of 30, and I'm going to write that out, and then I'm going to multiply 5 times the sine of 35, and I'm going to write that out. I am going to use my calculator for all of these problems in this section. I'm just not going to pull it out just yet. I'm going to hold off until I isolate my A. So in order to isolate A, I need to divide both sides by the sine of 30. So on the right side, I'll have 5 times the sine of 35, all divided by the sine of 30. And with that, I've isolated my A variable. So let's find out what A is using the calculator. Okay, so I'm going to type in 5 times the sine of 30. Check your calculator. If you're in degree mode, you don't need a degree symbol. If you're in radian mode, you want to put that degree symbol in. And that's supposed to be 35. 5 times the sine of 35 divided by the sine of 30. Watch your parentheses. Make sure you close parentheses when it comes to angles. And we should get 5.74 as the side length there for A. Okay, we've now got one of our angles and one of our sides. We have a third side that we need to solve for. So I'm going to push this all up just a bit, and I'll solve for that third side. So we need to find side C, and once again we're going to use the law of sines. So let's set up a proportion. And if I need to solve for C, then I obviously need a C variable. So I'm going to take the sine of angle C divided by side C. That will be one of my ratios. To finish it off, I can either use B or A at this point. We do have both. But if you use A, it's dependent upon the fact that you got this answer right. And so sometimes if we make a mistake here, that then affects our answer here. So I think it's a safer bet to go back to 130 degrees and its opposite side 5, just because those were given values. Once again, let's cross multiply. C times the sine of 130 equals 5 times the sine of 15. And then divide to get C all by itself. 5 times the sine of 15 over the sine of 130. And I'll use my calculator to approximate that value. 5 sine 15 divided by sine of 130. And we get 1.69. Okay, so you just want to make sure that you have solved the triangle completely. At this point you should know all 3 angles and all 3 sides. So we'll always have 3 pieces of information given, which means we'll solve for 3 additional pieces of information. Alright, so that's your most basic example of the law of sines. And again, this was an angle side angle example, and side angle angle pretty much works the same. So let's do an example of that.